Do you know what this is? This is a piece of Antarctica. In 2017, I got the opportunity of a lifetime and got my boots on the ice on Larsen C on the eastern side of the Antarctic Peninsula. I literally wrote my PhD on this ice shelf, so I brought a bit of it back with me as a memento. I may well live to see the day that this jar of melted snow is all that's left of Larsen C. Because, as we show in a new paper, this ice shelf, which has been around for hundreds of thousands of years, may not see the end of the century. Collapsing ice shelves are just one example of how climate heating is reshaping the Antarctic Peninsula. And in this new piece of work, scientists working from across many different disciplines got together to show how climate heating is reconfiguring this often forgotten part of Antarctica. We reviewed the published scientific literature to figure out how the peninsula will respond to human activity. And it shows that we have a choice. Act now to prevent irreversible damage, or lose one of the most unique and precious environments on Earth forever. The peninsula is this little bit that sticks out the top of the continent. And to those who say that size matters, it may be small, but it's still mighty. It's one of the regions of Antarctica that's warming the fastest. Temperatures there have risen by around 3 degrees Celsius since the 1950s alone, much higher than the global average. And although it contains far less ice than either of the other two colossal ice sheets, its unique environment and positioning mean it's exposed to much warmer temperatures, making it the canary in the Antarctic coal mine. The peninsula is the only place in Antarctica which has plants and exposed soil, which makes it a really unique environment for huge numbers of species, including mosses, lichens, insects, and birds. And the oceans around the peninsula and sub-Antarctic islands are teeming with life too, hosting penguins, seals, whales, and so much more. All of that is under threat from unchecked climate heating, and time's running out to prevent irreversible losses. In this paper, we looked at 3 different visions of the future. The first is a fairly optimistic one in which we limit average global temperature rise to 1.8 degrees Celsius above pre-industrial temperatures, what you might call well below 2 degrees. Another is an equally unlikely but still possible extreme warming scenario, in which we ditch any current progress and develop further fossil fuel resources rapidly. Both of these are included to show the range of feasible possible outcomes. But the last image of the future more closely aligns with the world that we currently live in, albeit, well, hopefully, with higher emissions. Whichever future we choose, the peninsula will continue to change. Processes within the ice, atmosphere, and oceans will amplify changes and cause cascades of effects across the ecosystem. But the amount of total heating will determine the amount of environmental damage. Every 1/10 of a degree of warming matters. In a world where we limit global warming to less than 2 degrees above pre-industrial, the changes are less severe. Warming continues and extreme events continue with a consistent frequency and severity. Ice shelves are stressed, but they remain mostly intact. Sea ice declines slightly, but stays roughly similar to today's. Ice on land remains largely as we see it today, and ecosystems mostly survive despite the additional pressures. This is a world which teeters on the brink, but stays stable. With more human-driven heating, the Antarctic Peninsula changes much more dramatically. Ocean temperatures rise more steeply, contributing to much more significant declines in sea ice coverage. That causes shifts in ecosystems as food webs are disrupted and important habitats are lost. Temperatures in the atmosphere rise even more sharply, leading to many more days above freezing, triggering melting. Higher temperatures also bring more snow and much more rain. Extreme events increase in frequency and intensity in both atmosphere and oceans. Marine heat waves cause cascades of impacts in ocean ecosystems which ripple out through the food chain. At the highest levels of warming, we see ice shelf collapses, including the Larsen C and Wilkins ice shelves. Without the ice shelves to hold them back, the peninsula's glaciers flow straight into the ocean and contribute tens of centimeters to global sea level rise by 2300. Same Antarctic Peninsula, 2 very different futures. But let's dig in a bit deeper to understand what makes these futures so different. Temperatures in the polar regions rise faster than across the planet as a whole due to something called polar amplification. Polar amplification is the reason that the Arctic is warming 4 times faster than the rest of the planet. And although it's not got as big an effect in Antarctica, it still causes the region to warm more strongly than the global average. Polar amplification happens because of feedbacks within the polar climate system, which amplify change. One of the most important ones relates to ice. Bright white ice is an extremely reflective surface, bouncing the sun's energy back to space like a mirror. Losing ice exposes darker rock or ocean beneath, which results in more energy being absorbed, which raises temperatures further, which causes more ice to be lost, and you can see how it kind of carries on. That's how a global average temperature increase of 4 degrees above pre-industrial can translate into a 5-degree change on the Antarctic Peninsula. Higher temperatures drive more frequent melting. That's especially true over ice shelves, which float on the ocean at sea level and so are exposed to warmer surface conditions. If enough melt happens every year, it saturates ice shelves with excess meltwater until eventually they fracture and shatter into a million pieces. It's happened on the peninsula before, and it can definitely happen again. Warmer air can hold more moisture, 7% more for every degree of warming, in fact. So in a future with higher levels of climate heating, we see more precipitation overall. But more of this will be falling as rain instead of snow. Today, around a quarter of the precipitation that falls over the peninsula during summertime is rain, so it's not uncommon. With more warming though, this fraction will likely increase to around about a third, potentially extending the summer wet season and threatening land-based ecosystems and breeding penguins. All these climatic changes on the Antarctic Peninsula are linked, and the plants and animals that live there feel their effects firsthand, or first flipper. The ecosystem in Antarctica is actually surprisingly simple. Marine microorganisms like krill form the basis of most seagoing creatures' diets. But with warmer ocean temperatures and a change in ocean conditions, those tiny animals will get pushed further south into colder waters, forcing the bigger animals that depend on them to move with them. The decline in sea ice and the increased frequency of marine heat waves threaten animals like emperor penguins, which rely on the floating ice for breeding. The dramatic crashes in sea ice in the early 2020s led to the failure of entire colonies of penguins to reproduce, and increased rainfall can kill chicks via hypothermia if it falls before they grow their waterproof feathers. On land, having more rainfall and less snowfall will reduce biodiversity by affecting the environment for lichens, mosses, plants and insects, and the habitat of nesting birds. As a result, there is greater risk of non-native species colonizing the Antarctic Peninsula, dramatically altering its unique ecosystem and biodiversity. And the changing environment opens up new challenges for polar operations and geopolitics. The peninsula is the region with the most national outposts. It's the least hostile part of Antarctica and therefore much easier to get to and to put personnel on. Lots of countries have a presence there, but nowhere else on the continent. Unpredictable sea ice conditions make it challenging to get ships in to resupply bases and move people around the continent. And with more rainfall and more melting, it becomes much harder to land aircraft directly on the ice because they get stuck to the surface and then can't take off again. Lots of world-class environmental research happens on the Antarctic Peninsula, and without the staff to do it, the science simply doesn't happen. Monitoring the pace of climate and biodiversity change is the bare minimum as the planet shifts. And in a world of increasingly lawless international geopolitics, there are other big consequences to these changes. A warmer climate with less ice may bring greater access to the continent and its resources. And when major world leaders refuse to abide by international law or treaty, that could spell disaster. With every increment of warming comes an increased risk of more intense change. That means more biodiversity loss, more ecosystem destruction, more warming, more extreme events, more ice loss, and a more unstable geopolitical environment. The danger is, if our choices push the Antarctic Peninsula too far, those changes will become irreversible. Once you lose an ice shelf, you ain't growing it back quickly. Which means that our actions today could lock in changes for millennia. The silver lining is that we think complete ice shelf loss would only happen with the strongest levels of warming and with the most intensive use of fossil fuels. So we have a choice on our hands, and as always, it comes down to priorities. We can choose to prioritize a livable future for everyone, or we can choose to line the pockets of a few billionaires at the expense of the rest of us. It's easier said than done, of course, because those few kleptocrats and megalomaniacs really don't want to give up their loot, but we really have to make them. Because it's not just about the Antarctic Peninsula. Obviously, I care a lot about Antarctica, but at 3, 4, or even 5 degrees of global average heating, it's really not the poles we need to be worrying about. That level of change comes with so many kinds of risks, including accelerating and intensifying extreme events like deadly heat waves, wildfires, floods, droughts, and storms. Temperatures in some parts of the world will reach levels that are impossible for humans to survive. At some combinations of temperature and humidity, your body cannot sweat enough to cool you down, and that can be deadly. In fact, if you want to be kept up at night, I would recommend reading the opening chapter of Ministry for the Future for a frankly harrowing account of what that specific scenario might look and feel like. I think we all know that we're going to be overshooting 1.5 degrees by quite some margin. It just ain't going to happen. Even the world of 2 degrees seems like a fantasy at this point. But as I always say, every 1/10 of a degree and every ton of greenhouse gases matters. So just because we're missing 1.5 and well on the way to 3 doesn't mean we should throw attempts to limit warming to 2 degrees out of the window as well. Everything we can do to minimize warming makes a difference. One thing that stands out from this work is that what we do next determines how hot it ends up getting. And that translates into real-world differences in the future that we end up handing our grandkids. We have a choice about who we elect, and a choice about what we buy, and a choice about how we live. Our leaders have a choice about whether they'd rather line their pockets with blood money or invest in a future that's worth living in. The choices we make this decade will cement the future we end up with. Would you look at that? Time's up. Thanks for sticking it out to the end. If you made it this far, chances are you liked the video. So if you want to see more videos like this, then please do like, comment, and share it far and wide. And if you're feeling extra generous, you can subscribe on Patreon. Patreon supporters saw this video first, and they fund me to make more and better videos. Stick around and watch this one next about how extremes are reshaping Antarctica. And I'll catch you in the next one. Ciao!